Hey guys, so this video here will go over the answers to the endo and exothermic slideshow, but more importantly, it will talk you through why those are the answers and give some more explanation about endothermic and exothermic reactions. I'm just going to zoom in here. So we know that exothermic is going to feel warmer than the surroundings, right? It's going to give off some energy. It will often feel hot. Whereas endothermic is going to feel colder than the surroundings because it's absorbing that heat, it's absorbing that energy, and therefore it's going to start out feeling cold. So let's start with the exothermic, because I think these might be a little easier at first. So lighting a match, anytime you've got flame and something is burning, that's going to be giving off energy. So if you're going to get burned, like lighting a match or lighting coals, then we know that would be exothermic. Both iron rusting and tarnishing silver is an exothermic reaction because what we're talking about here is oxidizing. And oxidizing is the same thing basically as a miniature fire. Burning sugar, that's why our bodies are hot, right? As we take in sugar into our bloodstream, it goes to our cells, we do cellular respiration, and that sugar is broken down into cellular energy that gives off heat. That's why we have an internal temperature of about 100 degrees. Nuclear fission, if we were to do, this is like what happens in nuclear reactors and stuff, right? If there was nuclear fission or fusion that was going to happen, it releases a ton of energy. Think about a nuclear bomb. Fireworks, that is certainly releasing energy, both light energy and light, light energy, a lot of heat, as well as a whole bunch of noise, giving off tons and tons of energy. Burning a candle, once again, you can get burned. Therefore, it is giving off heat as well as light. So the tricky one here is freezing an ice cube. The example that I've given during the other chemical reactions video, that if you put your hand behind your fridge or behind a freezer, not at the back of it, but behind it, where those coils are, it's going to feel hot. And the fact that it feels hot means that the freezer and the fridge are giving off energy, giving off heat as they are trying to cool down the inside of the fridge or the freezer. So in order to get that water to turn into solid ice, it needs to give away its energy. We need to get rid of that excess energy so that the water molecules will stop moving freely, but will actually freeze into a solid. So they have to get rid of energy, therefore it's exothermic. Of course, an ice cube feels cold, right? So that's where it gets a little tricky, is because we think about, oh, things feel cold, therefore it's endothermic. But in this case, it feels cold after it's been frozen, right? And if it's feeling cold and you're touching the ice and you are melting it, you're actually giving your thermal energy to the ice cubes, which cause them to melt. So that would be endothermic. Same thing with cooking. The fire beneath that frying pan is obviously going to be hot, but the food itself is absorbing that energy. Just like when you bake bread, you stick it in an exothermic oven, but the bread itself absorbs all that energy. It starts out as a mushy, wet bunch of dough, and then it comes out as bread after it's absorbed that energy. Same thing with evaporation, which is basically what sweating is doing, right? As the sun, in both cases, those are molecules, but as the sun gives off tons of energy, the sun being exothermic, that energy is absorbed by the water, which then turns into water vapor. It is more energy. Those water vapor molecules have so much energy they can fly all around. You absorb all of that sun's energy and you start to sweat. An instant cold pack, when you pop that, there's a chemical reaction from the chemicals in there that quickly create a cold, it cools and it hardens up inside of that cold pack, and now it will be absorbing your energy, right? It'd be feeling cold. That's why we like to put it on our hot forehead or something like that, or a bruise. Frying an egg, just like bread or cooking, the fire itself is going to be hot, but the egg is absorbing that and it turns from the liquid egg into a mostly solid fried egg. Once again, photosynthesis, the sun, exothermic, giving off tons of energy, but the plants are absorbing that energy. They're absorbing visible light energy, and then they are turning it into sugars inside of those plants. So as they absorb the sunlight, that's an endothermic reaction. Boiling, obviously the fire down here is exothermic. You could get burned, but the water going from liquid water to gas vapors. That means that they're absorbing energy to become more energized and float off into space. That's because the water has absorbed this thermal energy. So endothermic often feels cold, but it gets a little tricky when we're talking about, changing states here. If we're making it cold, that means we're getting rid of heat, right? The fireworks actually, as they explode, they will have less energy afterwards. They gave off all their energy, kaboom! And those fireworks at the end, after the explosion has happened, will be cold. They will have much less energy after that energy is expelled. Here, the ice melts because it's absorbing your body heat or the surrounding temperature of the air or something like that. So absorbing energy, giving off energy.